Hey, this is Adam Wise from Andor. I just wanted to show you some of the calibration options on this spectrometer, which is a Chimera 328, but it should be quite similar to the spectrometer that you're using. And I just wanted to show you what I meant by X-ray calibration by spectrograph. So it sounded like what you're doing now is a manual X-calibration. So that is just a lookup table between pixel number and wavelength. So for example, I could declare this wavelength to be 900 nanometers. It's not. This wavelength to be 1200 nanometers, and this wavelength to be 1400 nanometers. It might not like those arbitrary values because I don't know whether that's gonna be good. But let me calibrate. Scale not monotonic. All right, let's make a linear one. All right, so I just made that an arbitrary calibration function there. So the thing is, this only persists. This only works for one center wavelength because I've just made this table of lookup table of pixel number to wavelength. If I close this and I move my center wavelength, so I'm assuming, say this is right for this source. It's not, and pardon my line shapes. I have just took this thing apart and put it back together. This calibration function doesn't know anything about where the spectrometer actually is. It's just obeying that rule. So assuming that this is right, it's not, because it's a mercury argon lamp that I have hooked up. If I move this to say just somewhere else nearby, you can see the x-axis hasn't changed. So it's great for if you want to enforce your own arbitrary calibration function, but it doesn't persist. The spectrometer or the software isn't smart enough to update it elsewhere. So once you moved off that center wavelength, then you have to create a new one. Or you can, if you look in here, you can save this table as some kind of text file or config file, some kind of hashed text file, whatever, parsed text file. And you can reload it when you move to the same center wavelength, but none of that is automatic. So you could bring that back, or you could have several of these that would apply to several different wavelengths. And you notice here I've checked apply calibration to current data and apply calibration to new acquisitions. So moving forward, the software is going to use this calibration function. It's going to use that map of pixel number to wavelength. So to get rid of that and go back to the spectrometers automatically generated from the spectrometer geometry calibration function, I'm going to go to calibrate X-axis calibration by spectrograph, or X-calibration by spectrograph. And I'm going to give it a center wavelength. It doesn't really matter what you enter here. I just want to apply it to the current data set and to new acquisitions. And I'm going to calibrate it there. So now I'm back on what the hardware believes should be the correct x-axis generated from the grading equation and the spectrometer geometry. So this is just going back to that saved data, which is in the EEPROM, the configuration on the spectrograph. Now, when I change this, you don't have to change. You shouldn't ideally change any of this. If I do this, it'll change the grading. If I do this, it will move the center wavelength. I'm going to close this. So now I'm back using the automatically generated calibration functions. Now you can see my center wavelength is 570. And that's what it actually says. If I move it to 590 or something like that, you can see my x-axis is updated. So now it's being generated on the fly, kind of as I take acquisitions. You might ask, well, okay, what if I don't like that x-axis, or where is that x-axis coming from, or where are those calculated numbers coming from? So if you go into hardware spectrograph setup, you can see the geometry of the spectrograph that you're using to calculate that. And these are obviously, nobody measured it with a caliper or whatever, with calipers to 6 decimal places. But this was a best fit to a calibration lamp at a bunch of wavelengths during QC. You can mess with those values if you'd like to. Should you? Probably not. But you're always welcome to. Oops, I'm gonna turn that down for a minute. And you can mess with that here. You have to put in a password to change that, and now I'm remembering. If you want that information, I'll give it to you offline, just in case I need to give this video to somebody else who might hurt their spectrometer by changing the values. Normally, the only calibration, quote-unquote calibration that you'll be doing is applying an offset. So let me go back to 546.074, where I should have a line from the lamp here. And let me see how close I am. Yeah, quite close. So I'm gonna miscalibrate this, quote unquote calibrate this, just to give you an idea of what this process involves. So right now I have an offset for detector and a grating. So the detector is applied to all the gratings. It's an offset that's applied to the whole turret. Or I can do a per grating offset. So basically, if I were to apply an offset here, so there is already one that's got it on center. So say I were to change this to some other incorrect value. This is just a fudge factor that's added to, in terms of stepper motor steps, to the turret's position. So you can see now the line that should be at the center of my detector based on this wavelength is no longer there. I can auto adjust that, and I can let the spectrometer guide the I can guide the let the spectrometer guide the line back to here. And so this isn't a calibration in terms of you're not creating from scratch, or you're not updating the entire function for calibration. You are applying a shift that equally affects the entire x-axis. So you're just applying literally an offset. There's a grading offset that's per grading again. So now if I go to this grading, it's going to be a different offset that I can then update. Or were I to say remove the camera, put it back on, and it goes on 25 microns to the left or something, which is certainly within the tolerance of some screw holes, then I would apply this offset that should keep me from having to manually update each grading's offset. So that's the general idea. The actual calibration when I'm using X-calibration by Spectrograph is coming from the baked-in stored geometry of the spectrograph that was measured or that was generated during QC. Otherwise, if you use manual X-calibration, that literally is just for one view. All right, so hopefully we'll talk later about additional questions you might have, and I will post this video up to share with you as quickly as possible.